Hi students, problem number 6. A spring is connected to a mass M suspended from it and its time period for vertical oscillation is T. The spring is now cut into two equal halves and the same mass is suspended from one of the halves. Now the new period of vertical oscillation has to be determined. It's a very interesting sum. So I have drawn the picture relevant to that problem. So initially the mass M is attached to the bottom of a spring whose spring constant is K. So that its period of oscillation is T. So I will write an expression for T. So in the first case T equal to 2 pi into square root of M divided by K. So this is the first equation, the period of oscillation for the spring mass system. Now this long spring is cut into two equal halves is given, is it not? Now if a spring is cut into n equal parts, okay, suppose if the spring is cut into n equal parts, so initial spring constant, let us say K, so each part will have the same spring constant K dash. If they are all equal parts means all will have the same spring constant. So the new spring constant will be n times the original spring constant. So this is the fact or concept you are going to apply in this problem. So in competitive examinations, based on this, many numericals will be asked in the NEET and IIT. So when a spring of a certain length is cut into equal number of parts having equal length means or n equal parts means, then each part will have a spring constant K dash is equal to n into K. And here it is given two equal halves, is it not? So in this case, in our case, okay, K dash is equal to 2 times K because there are two equal parts, is it not? So that is the new spring constant for the smaller piece. So for this second picture, since the same mass is attached for a different spring, the period of oscillation I will call it as a T dash. So T dash must be equal to 2 pi into square root of the same mass divided by what? K dash. Now we have to determine what a T dash is, not? T dash has to be determined. So I call this as the second equation. I divide the second equation by the first equation. So dividing equation 2 by equation 1. So left hand side will become what? T dash divided by T. Now 2 pi and 2 pi get cancelled, is it not? So that this will become square root of M by K dash. So M divided by K dash. Now while dividing this by M by K root, the reciprocal can be multiplied. So into this is a square root of K by M. So that this root of M also get cancelled. So this will be equal to what? Square root of K divided by K dash. So T dash by T is equal to square root of K divided by K dash. But what is K dash equal to? 2K. Is it not? I am going to substitute K dash is equal to 2K. So I will write like this, or T dash by T is equal to square root of K divided by 2K. So that the K term will be cancelled. So this is equal to 1 divided by root 2. Or T dash is equal to T divided by square root of 2. So we have got the answer. The new period of oscillation is T divided by root 2. So which of the options is correct is option B. Therefore, option B is the correct answer. So this type of problems you will have to practice by assuming 3 equal parts or any number of parts. Sometimes they may give n equal parts. So in that you will have to take this nk. So you have to substitute nk. So t by root n will come, general expression. I hope you must have understood well. Fine.